Let's look at a new topic in physics. Yes, in physics, a new topic in physics under the JAMB Physics syllabus. Pressure in fluid and fluids in pressure. Two of them go together. Do you understand? So we have to look at what is pressure, the definition of pressure, right? We look at what the various formula is solving pressure, right? Problem regarding what pressure. Then we look at what these three calculation, right? So this is going to be the part one of this particular topic. We still have other topics, or we still have other subtopics under this one here. But under what pressure in fluid, yes, under what pressure in fluid, we are going to what is going to be two videos. This video and next video, which are because I cannot take more than three questions you are seeing here, right? So the next video we are going to explain more in-depth calculation, right? So let's look at what is pressure. So let's look at the pressure there, the formula in solving pressure there, the various units. They look at this one here. So let's just take a note here. So that pressure is defined as a force acting perpendicularly per unit area. So pressure equals to what? Force per unit area. Pressure, force per unit area. So with that stuff here, we can do a lot of things here. So here you can say pressure. The pressure equals to what? Force over what? Area. Idea, force over area. So it means that therefore P equals to what? F over what? A. Is okay. Now we can break some down because this F is also the same thing as weight. So you can say F is also the same thing as weight. And what now? What is weight? Weight equals to what? Mass times acceleration due to gravity. Do you understand? So we're going to be M what? G. This is that. So with this here, we can also actually break it down. So you can see that P equals to what? Mg over what? Over A. This is that. Mg over A. Now we can still break it forward. This is what is the pressure. This is what is mass. This is what acceleration due to gravity. This is what is the area. Do you understand? And the area will be what? Meter what? Square, right? Pressure will be what? No, this M will be what? This M you are seeing here will be what? Kg. Why G equals to what? Meter per second what? Square. Do you understand? So before we look at the unit here, let's break this down. Now when I talk about pressure of a fluid, now there's no way you know to talk about what density of that fluid, right? Every fluid have their own density, right? So remember, in the definition of density equals what? Mass over what? Volume. Either mass over volume, right? Now let's look at what the symbol of pressure. Pressure is like this. P, not capital letter P, just small letter P is equals to what? M over what? V. Is okay. There's a relationship between these 2 points here. This guy and this guy. There's a relationship here. What the relationship is? What is mass? So if you want to make mass the subject of formula here, mass, right? So what would be M equals to what? The pressure times what? The volume of the liquid. Do you understand? So what happened here? This is the mass of the liquid equals to the pressure, the density of the liquid times what? The volume of what? Of the container. Do you understand? So with this now, if you should impute it here, we always say like impute this guy here. So if you should impute one down here because two of them are related. They are related in what? In mass and mass. This one is what is density. This is what is spread. This is a capital letter. This one is small letter. Do you understand? So it means that if I want to relate two of them, what up here? In the place of mass, I'll put what? P. So you will I'll put what? Density times what? Volume. So it will be P, which is what is the pressure, equals to what? Now my mass is going to be the pressure, the density times what? Times the V times what? G over what? Over A. This is that. Now, it means that what? The pressure equals what? The density of the gas times volume of the gas times acceleration to gravity over what? Over what? The area. Right? Now, we can break this thing down here. The volume, we can break the volume down. Volume is equals to what? Equals to what? Area times what? The height. Is okay. Times height, because meter square times meter will go to give what volume, right? So if you should look at it very well, you're going to be what pressure equals what the density times what. Now instead of putting v, because here you can also say a times what times the height. It's okay, times the height. So that would be a times height times what g over what a, right? So if you check very, this guy will cancel out this guy here. What do you have left? You now left what with the density times what height times g. This is another formula you need to take note of. So now let's look at all the formulas again. It's very important. This is the first formula here. Again, this is what is second formula. Again, and this is the what, and this, if you look at this one here, this is what is another formula, and this is another what formula. So now let's write everything out here. It's okay, let's write all the formulas out. Let's just write all the formulas out. So the first one is P is equals to what? Force over what area. This is what is the model what formula for what pressure of a liquid. Do you understand? Next one is what P equals what mg over what a, right? Therefore, from here we got this one here. P equals what the density times what volume times g over what a. Can you see that? From there we now got this one here. P equals to what the density times what h times what g. So we have these three important what formula. No, not three. 1, 2, 3, 4. 4 important what formula. It's okay. Now let's start defining each of them here. Here we have what P is equal to what the pressure. Okay. And can either be what the pressure can either be what Newton per meter what square, either or Pascal or bar. Just and so there are different units in pressure, Newton per meter square. How do you get Newton per meter square here? Remember, force equals to Newton over area equals to meter what square. So if you combine it together, you're going to be Newton per meter what square. Just that. This Newton per meter square is also the same thing as what as Pascal. Just like in chemistry, pressure is measured in what in atm, that is the atmospheric pressure, and what millimeter what mercury. Just like that is going to be what for. They're going to be for chemistry. But in physics, the measure we want to look at is bar. So 1 bar is equal to what 10 to about 5 Newton per meter what square. Is okay. You also say that 10 is about 5 Pascal. So these are the things you need to know when it comes to what, when it comes to the unit of pressure. That's it you need to know when it comes to what unit of pressure. 1 bar, yes, bar, B-A-R, 1 bar equals to what 10 to the 5 Newton per meter square equals to what 10 to the 5 Pascal. Just it's very, very important. So next one to look at is what is my m equals to what mass, and it must be what in kg, right? G is what acceleration due to gravity. It's okay, sorry, I'm just trying to minimize space here. We what 10 meter per second what square, either 10 meter per second square here. This one you have seen here is what is density, and density because of what kg. Now because if you look at density here, density is equals to what mass over what volume. Yeah, the mass is what is kg, the volume is what is meter what cube. Is okay. So that is the unit of density got kg per meter what cube. Is okay. So density here we got to be what kg per meter what cube. This is that. Now A is what is the area. I which is what meter what square. This is that. H is the height. H is what is height. I which is what is meter. Right? So these are everything to know when it comes to what. They are everything when it comes to what pressure in liquid. So these are all the formulas These are what that definition. So please take down so I can solve this problem here. So now let's have what the first question here. Very important here. Now this is the type of question you like to see what in the exam. This is the type of question you like to see in your exam. This is that a rectangular water tank of weight 4.5 times 10 to what 3 Newton measure 2.0 meter by 1.5 meter by 1.2 meter. Calculate the minimum pressure it can exert when resting on the horizontal surface. So how do you solve this problem here? Please pay close attention here. If you check very well, they gave us the force. They gave us force to be what? 4.5 times 10 to what? 3 watts Newton, right? 4.5 is 3 watts Newton. That's what they gave to us here. Look at these are the volumes 1.2, 2.0 by 1.5 by 1.2. So look at something here. You have 2.0 meter times by 1.5 meter by what 1.2 watts meter. Look at something here. To calculate pressure is very easy. Pressure equals to what? Force over what area, right? Also give to me this is what my volume. So how do you get the area? That is the question you need to ask yourself. Now to get the area, we need to look at the statement here. Calculate the minimum pressure. Now look at something here. The larger the area, the minimum the volume. No, the minimum or the pressure. Now how do I say it here? The bigger the area of the base, the minimum the impact of the pressure. Just but the smaller the area, what happens? The maximum the pressure. Look at some the maximum the pressure. So when you talk about minimum pressure, look at something. There's what you want to know here. You want to understand minimum pressure. Minimum what pressure is equal to what maximum what area. This is one thing to put in mind. It's okay. Minimum pressure equals to what maximum what area. So to get minimum pressure, you need to get what the maximum area. To get maximum pressure is equal to what minimum what area. Please, you need to take this down. Very important. So there are things you need to take note here. So now they say minimum pressure. That is, we need to get the higher watts area from this point here. This is the higher watts area from this point here, because my force was 4.5 is 3 Newton. Now these are the values given to me. How can I get the maximum area? Just understand that minimum volume, minimum pressure equals what maximum what area. Take note of it. The maximum pressure equals what minimum what area. Do you see that? So how do you solve this thing here? Now, because I'm going to get what my maximum what area. So from here, how can I get what my maximum area? Here we have 2.0, and here we have 1.5, and here we have 1.2. Now, I'm going to take what the highest value, because when we talk about maximum, I'm going to take the highest values. Now, this one is higher, right? So the 2.0 meter times out of this and this which is higher. 1.5 is higher than this one here. This one is higher than two of them, right? That will place it here, right? Then this one is higher than this other one here. Here we have 1.5 meter. Is okay. So to get what the maximum area, you know, get what the two highest value given to us. Just now. So you're going to do what 2.0 meter times 1.5. 2.0 times 1.5. Here we have 3. So going to be 3 watts. Going to be 3 meter watt square. This is 3 meter watt square. 3 meter square. So that is my pressure now equals what force over what area, right? Now what's my force? 4.5 exponential what 3 Newton over my area is 3 meter watt square. Can you see that? So what happened here? So you have 4.5 exponential 3 divided by what? 3. Then we have 1,500 what? Newton per meter what square. Can you see that? So this was my question what one. My question one. This was my question one. Now look at what question 2. How do we solve question 2? Right? It's still the same here. If you check very well, it's still the same here because here it says a rectangular block of dimension 2.0 meter times 1.0 meter times 0.5 meter weighs 20 Newton. Right? So if you look at the force here is what is 20 what Newton. So I want to get the area. Is okay. How do I get the area? So let me ask it. They say maximum pressure. Can you see that? Here means what? Here minimum pressure. Remember, minimum pressure equals what? Maximum area, right? Maximum pressure equals what? Minimum what area. So now if I say, how do we get our minimum what area here? You have to take the lowest. You have to take the lowest. For this guy, which one is lowest? This guy is what is lowest. It's okay. So here you can say area 0.5 meter times. Now we have taken it from here, right? So for here and here, which one is the lowest? 1.0 is what is lowest, right? So here we have 1.0 meter. So to get what my minimum area here, I'm going to multiply the two least value given to me, right? So if you want multiply it here, you have 0.5 times 1.0, you have what? 0.5. So you have what? 0.5 what meter what square. This is that as easy as that. So they are asking us what to calculate the pressure, right? Pressure equals what? Force over what? Area, right? Equals to what? My force is equals to 20 Newton over what? 0.5 meter square, right? So you have 20 divided by 0.5. You have what? 40. So we got 40 Newton per meter what square. That is it. As easy as this. Just now let us change the value here. Let us say we have 9.8, right? And let us say 3.1 meter by 2.8 meter by 0.6 meter. Is okay. Let us change value here. Let us change value. You understand? So we change value here. Solve this question one. Leave your answer in the comment section. So now let us change it to what? To 60 what Newton, right? So let us change it to what? 2.8 meter. Is okay. 2.8 meter. Right? Let's look at what 2.8 meter. 2.8 meter. Let's just say 1.76 meter. Here we have what? No before. Let's say 1.1 meter. Is okay. So go ahead and solve question 1 and question 2. I just change value here, right? Use the approach I've taught here to what solve question 1 and question 2. So let's look at what question 2 and what question 3. A reservoir is filled with a liquid density. So the density is what is 2,000 kg per meter cube, right? Calculate the depth. When they say calculate the depth, they ask you to calculate the height. The height at which the pressure in the liquid will be equal to this, right? So the pressure given to me, pressure is what is 9100 Newton per meter what square. This is that. Now the height, because when they say the depth, they're talking about the height. So it's going to be the height you are looking for. Right there. So whenever you're talking about height, understand that you're going to include what G, right? Which was 10 meter per second square. Is okay. So which formula can we use? Remember, P equals what? Force over what area. You need to learn how to derive this formula. You understand? You need to learn how to derive this formula here. So we have mg over what? A, right? But none of these are here, right? As a matter of fact, it's only G we have, right? Now remember, my density equals to what? Mass over what? Volume, right? So if you mention the same formula here, m equals to what? Density times what? Volume, right? So will it be equals to density times volume times what? Times g over what? A, right? If you break this one down, this volume I'm saying here is what? Is area times the depth, which is the height, right? So if you check very well, it's going to be P equals to what? The density times area times the height times G over what? A. This guy becomes out this one here. So here we have what? Density times what? Height times G. Just so now my density is what? My density is what? Is what? 2000 times. It's okay. Times. So my density is equal to what? So now the formula we are going to use here, that is formula we are using is what? Is P equals to the density times the height times G. So now the asking of the depth, which is the height here. So you have to make this guy solve formula here, which is going to divide by E times what? G. Is okay. This will cancel out this guy, this will cancel out this guy here. It means that my height, which is the depth, is equal to what? P over the density times G. This is that. So input your values here. We what? 9100 over, right? My density is what? Is 2000 times what? G is what? Is 100. This is that. So let's get our answer here. So you have 9100 divided by, you have 2000 times 10, 0.455. So going to be what? The height here, A equals to 0.455 meter. This is that. You can see how easy it is. So this thing is not actually what difficult, right? This is not actually what difficult. Please, what I want you to do so far is this: go to the past question and see all the questions related to this one here and try to what solve them. So we are done with this. Now let us say here what is 5,000. It's okay. Now let us say here we have what 7. Yes, I've changed the value here, right? Go ahead and solve this T question. Question 1, question 2, question 3. Just go ahead and solve this question. Look at something here. Some of you have bad habits. Like I keep on saying this here. Each of my videos, keep on saying it. Some of you have bad habits. When I say solve, you will not solve. Now the only way you can actually master it here is by solving that stuff. Drop your answer at the comment section. If this video is helpful, please leave a comment section. This video is helpful. Thanks for watching. See you in my next video.